Ever wondered what makes the current in your electronic devices flow in one direction only? Enter the world of diodes, the unsung heroes of electronics. These tiny yet mighty components work tirelessly behind the scenes, ensuring the current in your devices takes a one-way route. From your smartphone to your microwave, diodes are an integral part of almost every electronic device around you. Intrigued already? Stay tuned as we unveil the magic behind these tiny yet powerful components. The diode, a two-terminal electronic component, is the master of one-way traffic in the world of electronics. Picture this. The diode is a bit like a doorman, only letting certain guests in. These guests represent the electric current, and the door they're passing through is the diode. Now, our little doorman has a name for each of his two doors: the anode and the cathode. The anode is the entrance, welcoming the current in, while the cathode is the exit, ushering the current out. And here's the catch. The current can only flow in one direction, from the anode to the cathode. This one-way system is the key function of a diode. It's like a strict rule that our diode doorman enforces, making sure the current doesn't get cheeky and try to sneak in the wrong way. But you might ask, how does this tiny traffic cop manage to control the flow of current? Let's dive deeper. The secret to a diode's one-way control lies in its clever use of semiconductor materials. Now let's delve into the heart of the matter. A diode, in its simplest form, is composed of two distinct parts: a piece of N-type and a piece of P-type semiconductor material. The N-type material is a bit of a party animal, brimming with free electrons, always ready to jump into action. These electrons are negatively charged and are constantly on the move, contributing to the current flow. On the other side, we have the P-type material. This is the introvert of the semiconductor world. Instead of an abundance of free electrons, it is filled with holes. These holes are not literal voids, but spaces where electrons can fit. They are positively charged and are always on the lookout for free electrons to fill them. Where these two contrasting characters meet, a fascinating phenomenon occurs. This junction becomes a sort of no man's land known as the depletion zone or barrier. It's like a wall at a high school dance, separating the boys or the free electrons from the girls or the holes. Now, this barrier is a game changer because it prevents current flow. Remember, the current in a diode can only flow in one direction, from the anode, P-type material, to the cathode, N-type material. When the voltage isn't applied or is applied in the wrong direction, the barrier holds strong, keeping the current at bay. However, the magic happens when voltage is applied to the diode in the correct direction. This gives our free electrons just the nudge they need to overcome the barrier, allowing them to fill the holes in the P-type material. The barrier is reduced, and the current is allowed to flow. So when the voltage is applied to the diode in the right direction, this barrier is overcome, allowing the current to flow. This, my friends, is the fundamental principle that makes diodes, and indeed all of electronics, possible. Now that we understand the science behind it, let's see our tiny traffic cop, the diode, in action. When voltage is applied in what's called the forward direction, with the positive side connecting to the anode and negative to the cathode, something fascinating happens. The barrier that was previously preventing current flow suddenly lowers, opening up a clear path for the current to happily zip through. However, change the direction of the voltage, apply it in the reverse direction, and the scenario flips. The barrier, that friendly doorman, becomes a vigilant guard. The height of the barrier increases, effectively blocking the current and preventing it from flowing in the wrong direction. This one-way street, this unidirectional flow of current, is what we call rectification. And just like that, the diode ensures your electronics function as they should by controlling the flow of current. So there we have it, the diode, a simple yet powerful player in the world of electronics. We've journeyed through its structure, its reliance on semiconductor materials, and its crucial role in rectification. These tiny components, often overlooked, are the gatekeepers of electrical current, ensuring it flows in one direction only, maintaining the harmony of our electronic devices. Remember to hit the like button if you found this explanation helpful, and subscribe to our channel for more intriguing insights into how your electronics work. Until next time, keep exploring.